A few moments later.
Why is it so hot in here? Jose! Why did you close it?
Oh, I thought I closed it.
Why is the room so hot?
Have you ever wondered why your room becomes warm even though your refrigerator door is left open? Refrigerators, which have been an integral part of every household, work based on some simple and interesting scientific principles. Beginning with the simple refrigerator model, I will elaborately explain the operation of modern refrigerators along with the secrets behind the high energy efficiency.
The basic principle of refrigerators is simple. Simply pass a colder liquid continuously around the object to be cooled. Let's see how this continuous cold liquid flow is achieved inside the refrigerator. A simple device called the throttling device is the most crucial component of refrigerators.
Here, a capillary tube is used as the throttling device. A cold liquid is produced using the throttling phenomenon. For effective throttling on the inlet, the refrigerant should be at a liquid state under high pressure. The throttling device is an obstruction to the flow, so a huge pressure drop occurs when the liquid flows through it. Leaving you with 10.4 atmospheric pressure and 7.9 atmospheric pressure. As the pressure drops, the boiling point of the liquid comes down. Thus, the refrigerant liquid evaporates. The energy required for such evaporation comes from the refrigerant, so its temperature drops. If you check the temperature across the throttling device, you will notice this drop.
Please note that only a portion of the refrigerant is evaporated here. This is one important property of the refrigeration fluid. It should be able to change the phase while varying the pressure under normal temperatures. This is Jane, and today she will show you how to derive and solve for a missing variable in the formula of the ideal gas law.
This is the formula used in the ideal gas law, which will further explain how it is possible for an enclosed room to have a high temperature even though the door of the refrigerator was left open. First, you need to derive the formula in order to get the final temperature of the refrigerator through cross multiplication. Then, divide both sides by initial pressure and initial temperature to get the final temperature. Second, place the values to compute for the final temperature. And lastly, input the values in the calculator to get the answer. Remember not to forget to put the unit, which is Kelvin, in your answers.
Other real-life situations that use the ideal gas laws are the air conditioner and hot air balloon. That's all. Thank you for watching, and I hope you learned something about the ideal gas law.
Mom, what just happened?
I think we just learned about the ideal gas.
So that's why the room was so hot.